Alright guys, so in this next video, let's go ahead and talk about a very particular circle, which we call the unit circle. What the unit circle means, just if you guys are unsure, it basically means a circle with a radius. I should probably type this out, so let me go ahead and type that out. Why not? Let's go ahead and type this out. It's a radius, the unit circle is a circle with a radius of 1 length, or 1 unit. Basically what this is saying, guys, is this is any circle that has a radius of 1 centimeter, 1 inch, 1 meter, 1 mile, 1 whatever length. That's all it means. So basically what we know of here is it's a circle. If I write a circle like this, the radius, okay, if I draw a radius right here, this radius is 1. Very nice. That's it. You might go, wait, what? That's the foundation to a big part of calculus? Well, yeah, you got that right. It's just a circle with the radius of length 1. And we can begin to kind of do some interesting stuff. So because we have a circle with a radius of 1, let's go ahead and let's draw something here. Let's draw our famous X and Y axis. Okay, so here we go. Boom, shaboom. So we know that here's our circle. Let's draw the perfect circle. Well, the unit circle is one that has a radius length of 1. So length 1. This is going to be length 1, but because we're on the unit circle, it's -1. And because we're on the unit circle and we're down here, this is also -1. And just to be clear, the X value is 0, the Y value is -1. This is 1, 0. And then up here it's 0, 1, just so that we can organize the actual coordinate points, -1, 0. Now, yes, this is a circle with the length of 1, but we're putting it inside this basically X and Y axis. Now, we're going to basically just draw our perfect circle. Oh my God, my circle is beautiful. Oh, I kind of messed it up over here, but this part is amazing. All right, so here we go. We got a circle with a radius of 1 all across, right? Meaning anywhere on here, starting here to here, radius 1, here to here, radius 1. Okay. Now, what is the circumference of our circle? Right? What is the circumference of this unit circle, this very special circle with a radius of 1 length? Well, the circumference of this, if we go ahead and use our formula, circumference is equal to 2 pi times r. Well, circumference is equal to 2 pi times 1, because the length is 1 for the radius. So we have that our circumference is 2 pi. Now, what does this mean? Well, all this means, guys, is let's say this was a radius of length 1 centimeter. Well, if I plug this into my formula, my circumference is 2 times 3.14, approximately 6-ish centimeters, right? Ish. I'm too lazy to pull out the calculator. So that tells us our circumference is approximately 6-ish centimeters. Now in math, we don't want to, especially in higher advanced math, we don't necessarily want decimals anymore. We want to have exact figures. So what we decide to do is leave it as pi's. Now these pi's we call radians, all right? So what does this mean, guys? What this is telling us now, okay, is if you go around a circle all the way through, the length of that is 2 pi. You go around a circle once, it's 2 pi using our formula here. That's the circumference of a circle. Now, if I go half a circle instead of a full way through, right, if we rationale through this, well, then this would be half. This is pi. Because going around was 2 pi, this is pi. So you can see here that we're just cutting it in half and getting these measurements across our circle. Now, why is that important? Well, it's important for us, guys, because we want to be able to measure our circle using radians instead of degrees, right? If I go around a circle, it's 360 degrees. Now, here's the issue, guys. 360 degrees is kind of made up. The ancient Babylonians thought there was 360 days in a year, and that's why they put 360 tick marks. Well, we're not using that because that's not really mathematically sound, but we have a mathematically sound formula that is scientifically working for us, and we've used it to mathematically show that the length around a circle is 2 pi. Now, that is our radian measurements, all right? So how can we begin to go and cycle through this? Well, let's fill out these 4 points, okay? So we're gonna start here. Now I want you to kind of think this through. If I go around a circle, it's 2 pi. If I go half a circle from here to here, it's pi. What did I do? I just cut this in half. If I cut this in half again, well, this is half of pi, so pi over 2. So this is, right, if we start off, this is 0. We go pi over 2, pi. What would this length be here? And then what would this length be here? Well, it's 2 pi. Now we're just missing this bottom portion. Now, trying to fill in this bottom one can get a bit confusing, right? This can get kind of confusing, so we want to have a system to be able to go ahead and fill this in very nicely. Now, this is where geometry comes into play, guys, because a part of filling out this circle, well, we're going to use geometry because we can actually make a right triangle inside of a circle. And there are 2 special triangles that we know of in geometry. We have our, let me draw it down here. We have our 45-degree angle. It's a very special triangle. And we also have our 30-degree triangle, which is also very special for us. So in this next video, we're going to talk about how geometry pretty much plays a big part into what we're going to utilize with this circle. So hopefully that makes sense, guys. Hopefully you understand kind of what we're doing here to basically get ourselves these 2-3 spots of our circles, point wise, radiance wise, and we're obviously missing this one, which we'll talk about later.